Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, the ABCs of Service Enclosures. My name is Amanda Rogers and I will be your host for today. Firstly, in keeping with our tradition, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their cultures and to elders past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Echo. Echo in Australia offers us an extensive portfolio of stormwater, building drainage systems, cable pit and ducting systems, access covers and other niche products. The company have just celebrated 25 years as Australia's foremost manufacturer, with facilities in Western Sydney and New South Wales. Echo takes pride in providing excellent customer service and extensive technical support, from specification to the finished product installation. And I'd like to welcome our first speaker for today, Bruce Potter. Bruce is a Senior Utility Coordinator at Carno, who is a Chartered Engineering Technologist and registered on the National Engineering Register. With over 20 years' experience in civil engineering design and subsurface utility industries, Bruce specialises in subsurface utility engineering and public utility plans, encompassing professional utility coordination and utility relocation design, utility data management, field gathering and utility asset management, from feasibility through to detailed design and construction and superintendency. Bruce represented Engineers Australia in the development of the Australian Standard AS5488 in 2013, classification of subsurface utility information, officially released to the public in July 2013, and Working Group Committee member of the AS5488 Upgrade Part 1 and Part 2, released to the public in May 2019. Please welcome Bruce Potter.
Thanks, Amanda. My presentation today is in two parts. The first part talks about understanding subsurface utilities and their data, and the second part talks about the access lids, pits and manholes. So we go into the first stage of understanding subsurface utilities and their data. So when you go walking down the street, quite often we don't actually know where most of the subsurface utilities actually lie in the ground. The only way we can actually see them is the visual cues we get when we see the pits and manholes. Some of them are circular, some of them are triangular, some of them are rectangular. They all present that there is a subsurface utility underneath. How we obtain this information, the very first step is to lodge a die before you dig request. Or in the case of a private entity, contacting the GIS department, or in the case of schools, potentially the groundskeeper or anything like that. The information that we get from DIAL's information, it's not validated, so therefore it's considered as Qualifiable D in accordance with AS488.1 2019. And should only be used as an indication there's a presence of utility. In most topographic surveys we get in the engineering design world, most of the lids are generally picked up by the surveyor doing a topographic survey. And these are portrayed normally as Qualifiable C to AS5488.1 2019, and they're generally classed as a surface feature. So some of these you might see, so there'll be a point representing a pit or a manhole, or there could be some of the larger features which would have the four corners of the pit displayed and recorded the attributes of who owns that information. When you combine this information that you see on a survey with the die before you dig information, or in some cases the data you receive from a private entity, it gives you an indication that there is something below the ground. But we still don't know the accuracy of it. We still don't know a lot of the data. So the only way we can really obtain further data is by calling in a utility locating company and undertaking potholing. The utility locators are the link on the ground that binds the utility owners and the design and communicate and the construction community together. They are very, very experienced in what they do. They understand how to read dial before you dig plans. They understand the technologies available to find this information. Then the dial before you dig certified locator came out a number of years ago, and it is a similar type of program that Engineers Australia have with the chartership program. So dial before you dig certified locators, they are subjected to a theory test and a practical test, and they are subjected to CPD, and they need to be they need to go in for reassessment each 2 years. So what type of locating equipment is available to the arsenal of a utility locator? Well, the one on the left is radio detection, commonly known as the wand. It's generally used to try and find radio waves of existing assets of electricity and telecommunication assets, and is widely accepted as the most preferred method of using to locate existing assets. The one in the middle is tractor-mounted CCTV, and that's where the locating company would actually open a pit or a manhole, and they would lower the tractor camera into the manhole itself, and they would take some footage of the condition of the existing manhole, and then drive the tractor camera through the pipe, taking observations of the camera itself, of the pipe itself. Some of these tractor-mounted cameras can have sondes located on the top of them, and that gives the ability then to trace where the tractor camera is going through the pipe itself. So it can be traced on the surface level, similar to that of a radio detection unit. The other one on the right, most engineers have seen this before, but it's called ground penetrating radar. And they're generally used where you can't actually access an existing utility by a pit or a manhole, and they are essentially tracing the asset by scanning the information that's on the ground. So that could include tree roots, it could include voids in the ground, as well as the actual pipe they're trying to find itself. So again, they're good for tracing water mains, sewer rising mains, and gas mains, where there's no physical pit or manhole they can physically access to get into it. The great thing about utility locating is that they're able to provide meaningful information about pits and cables and pipes and all sorts of interesting sort of things. So the picture on the left shows a CCTV WinCam report. The top two pictures on that right there show the inside of the pit and manhole. So engineers themselves can actually start to get an idea of what these conditions of the existing assets are. The bottom three pictures, they show potential problems with the pipe as the tractor camera drives through the pipe itself, and the operator then determines what kind of problems there are. These guys are trained in understanding the different terminologies with the codes from WASA 2008, and their different coding. See there on the text in black and red. Red obviously means that there is something wrong with it, and then in black there's observations there that that generally could be something noted in there. On the right is where generally a utility locator would come along, who would use radio detection and GPR. When they're using radio detection, by default, they have to clamp onto an existing cable that's in the pit itself, or use trace rods to conduct the a presence of a cable in there. And by default, they're able to actually open up the pit lid and look inside to see what the configuration of the conduits are, what condition the conduits are at the pit itself, and generally what the condition of the pit overall looks like. So is the existing pit structurally deformed? They would take note of all that information as well. So what does this all mean? I'm sure we've walked past a few of these before, but it's basically called street graffiti, and the different colours on the ground actually mean there's been a different asset identified by a utility locator. So white would generally mean it's a communications asset, orange would mean it's electricity asset, blue would indicate it's a water main asset, yellow would be a gas main asset, green would be a stormwater or drainage asset, green or sometimes purple would represent a sewer, and magenta colours would mean something unknown. These can be changed a little bit on site depending on whether they are doing these investigations during the day. If they're during the day, it's pretty much as what you see on the screen there. If it's at night time, some of these colours don't show up that well, particularly with green. Sometimes I'll use a white colour in lieu. When you combine utility locating and vacuum excavation, you'll get potholing, and that's where we're identifying where the utility is by marking it up on site, and then getting a vacuum excavation unit to dig the area to confirm the depth of the asset and what material it is, all that sort of thing. So you can see on the right-hand side there is a pothole that's been taken of an existing water main, and that water main looks like that there is a plastic blue brute pipe. The surveyor would then come along and take the depiction of that asset itself and record that digitally. So what does this all mean together? Well, it all means that we can look at this in a 3D world, very different to what's happened in the past. With the smarts of surveying and the information provided by the utility locating professionals, put those two together and you can actually get some really good information in a 3D source that we can use to fly around in our different modelling packages and things like that to understand what currently is in the ground. So to wrap up this first portion, look around you when you walk down the street, and you'll be surprised to see how many existing asset lids you'll actually see. You also need to understand the quality levels from AS 5488.1 2019. In that standard talks about the 4 quality levels: quality level D, which is base level data, quality level C, quality level B, and quality level A. And from quality level D all the way through to quality level A, you're actually increasing the level of accuracy and decreasing the amount of risk that you have associated with that information. The other point to note is die before you dig inquiries. Their mantra is it's the essential first step. That information is free to you, and it is valuable information, and I highly recommend that everyone does that to begin with as baseline. The other thing to note for most engineering professionals is to actually understand the utility locating equipment that is available, and to understand the limitations and what you can actually get out of that data. That is very handy when you're looking through information provided by a surveying company or a locating company, and you were trying to actually understand what information you have. And then probably the last and probably more important thing is utility locators. They are one of the first to give us an indication that there is something wrong with an existing asset, being a conduit, a pipe, the access lid, the pits, or the manholes. So now we move on to the second part of this presentation, and this is all about pits, manholes, and lids. So pits and manholes are everywhere. They're absolutely everywhere. So when we start a project, they could be in greenfield projects where we're doing subdivisions and industrial and commercial precincts, where essentially there's no existing assets there and we're putting those assets in to facilitate the buildings that are going up around it. They could also be in brownfield projects where essentially you've got road and pavement rehabilitation projects, or you're retrofitting, which could include raising or lowering existing pits and manholes to suit the new surface levels. And then you've got relocations or where an asset owner comes in and puts another asset in. And that's a combination of in greenfield projects and in brownfield projects. But the main thing to note here is that in each category, there is non-trafficable and trafficable lids, pits, and manholes that require differing factors to consider depending on the application and design that you are trying to achieve. So for non-trafficable assets, they are normally found in footpaths and pedestrian-centric areas. With these, they have the benefit of interchangeable pit lids, which can be matched to the surrounding aesthetics, and they can be coloured infill concrete lids. So rather than having your standard lid that the asset owners may have, which is generally a cast iron lid, they can be interchanged out, and as you can see there, they can match in with the aesthetics of the area that's surrounding it. So for minor assets, pits and manholes generally have a similar dimension. So you'll see that as you walk down a residential street, see most of the time the Telstra and Energex pits are a stock standard size, and the pit below it is generally also around the same size. But there are the occasional exceptions where a deeper and or major utility, a chamber, which is basically a big concrete structure below the ground, below the lid itself, could be present and is much larger than the lid itself. And this can cause a lot of coordination issues in a lot of the designs that we have. So some of the aspects of non-trafficable lids and pits, from a safety design perspective, they're generally a lower risk because they're in areas of pedestrian-centric. That still means that we don't ignore a lot of the issues. We still need to consider the pedestrian management for inspection and maintenance, particularly during the day. So if you've got courtyards, if you've got verges and things like that, outside people addresses and things like that, they still need to access those, and they're generally during the day. The only exception for this would be in heavily populated areas such as capital city CBDs, where you have a high volume of people accessing the non-trafficable areas during the day, and that would be done at night under traffic control conditions. The other thing to consider is that they generally conform to standard corridor offsets. So when you look at council specifications, the horizontal and generally the typical depth of those assets, they generally follow the same mantra for subdivision and industrial precincts. And they also generally conform to standard government drawings and specifications. So now we move on to trafficable, and this is where these assets are located in roadways predominantly, or in areas where they're accessed by a vehicle. So you could have a pedestrian-centric area with nice pavers on top, but they could also be a trafficable area as well. Now, a lot of these pits and manholes, the lids themselves are cast iron, and they are right in the middle of the roadway. So again, for smaller assets, the pits and manholes themselves could be a similar dimension, with the only difference being is that there would be a cast iron lid instead of a non-trafficable lid. Again, for deeper and major assets that are running down the road, a chamber could be present and again causes lots of problems in coordination. So don't be fooled by having a smaller access lid on the surface level and believing that the actual utility underneath, and the chamber in particular, is the same size. So for considerations, safety design perspective, they are generally higher risk because they're in a trafficable area. When we're designing these assets, they need to consider the temporary shutting down of road lanes. So generally, these assets need to be put right in the middle of a laneway or off to one side of a laneway. This allows for a bit of consideration for the inspection and maintenance, mainly for night works. Again, if you're in a residential street, they could do this during the day. In a capital city CBD, most likely night works. And if you're in areas where you've got multiple different asset owners, so a council versus a main roads entity, again, you've got coordination with a lot of these asset owners and operators and authorities to come together. Sometimes the assets themselves are non-standard. They're much deeper than their counterparts on verges, and that is to counteract the traffic loading. And again, there's a coordination approach between the approval of asset owners and authorities, designers, engineers, and construction teams. So just to sum up this portion here, pits, manholes, cables, and pipes, they're absolutely everywhere. They don't discriminate against projects. They don't discriminate against any boundaries that you put on there. Utilities go from one point to another point. The other consideration here is to understand the differences between non-trafficable and trafficable access lids and pits. And with trafficable lids, they are generally not interchangeable. They are generally limited to cast iron that provide the sufficient design loads for roadways. For non-trafficable lids, they are generally interchangeable or can be interchangeable, and they can match the surrounding aesthetics in that area. And note for both that chambers could be present that are much larger than the access chambers themselves. But it's always important to understand the limitations you have in design, particularly with the case of getting a utility locator in, opening those pits, manholes, and determining what size the chamber is underneath, and surveying that to reflect what is actually under the ground. So that concludes my presentation. My contact details are on there, and I'll hand back to Amanda.
Thank you, Bruce, for your insights. I'd now like to welcome our second speaker, Greg Facey. Greg Facey is the Market Segment Manager for Echo, a family-owned global organisation specialising in the manufacture of products for the construction and building industry, with its Australian manufacturing plants in WA and New South Wales. Greg began his career with the organisation back in 2014 as Queensland Specification Representative, providing education and project solutions to many state authorities, engineering and architectural firms. Greg progressed into the current market segment role, providing education and CPD support, technical advice and design brief development nationally to industry associations, transport authorities and designers in the stormwater management space. Please welcome Greg Facey.
Hi, and welcome to today's webinar. My name is Greg Facey. I'm the Market Segment Manager for Echo. Today in the industry, there is a wide range of trafficable cable enclosures in various types of materials, including non-conductive plastic, cement concrete, GRC, which is a glass reinforced concrete, and polymer concrete. There's also a wide choice of lids and access covers to meet the anticipated load requirements of the project. The covers can vary from non-locking and standard locking to high security designs to meet specific client and government requirements. Cover and frame systems also provide secure protection to cable enclosures and enable decorative floor finishes to be maintained without minimal interference. Today, in this webinar, we'll discuss some of the key requirements required when selecting service enclosures, the cover and frame systems, and it's also important to understand the correct enclosure for the application. So today, you will receive an understanding of the types of enclosures, their uses, and the factors to consider when specifying them across a wide range of applications, and an understanding of the lids and access covers and how they can affect the performance of the enclosure itself, as well as their physical and visual integration with pavements. Because incorrect product selection or poor product choice or poor product materials and incorrect assessment of the site conditions can lead to failure of the systems. And this can include either failure of the lid or the cable enclosure or both. So failures occur for a wide variety of reasons. However, understanding all the aspects of the enclosure system is critical for long-term performance and durability. So let's consider surface pits and surface ducting. Let's start by looking at the different enclosure types that are available on the market today. Cable pits are positioned on cable routes to provide either branching or bending points and to allow access for jointing and maintenance. Common cables routed through cable pits include data, communication, fibre optic cables. Traditionally, these are low voltage electrical wiring, where higher voltage cables typically go overhead or a lot deeper or extremely deep underground. In contrast, surface cable ducting systems become the cable route and allow low voltage cables and other utilities to be laid effectively towards the surface and along the trafficable management pavement. So they can be continually accessed through removable covers, and the structure and the enclosing of the surfaces is typically continuous. So these are often in the form of a precast sections for smaller widths, so generally up to 300 mil wide, or cast in situ systems for wider width requirements. So sometimes often we see these in widths from 450, 600 wide, 900 wide, so it can be a lot wider for a lot more larger amount of services that has to be routed through that system. And there's also a number of specialist pits and enclosures that are available, and these have unique features which are designed to suit niche applications. So a cable enclosure is designed to protect its contents, cables, connectors, equipment, etc., against external influences. So the structure also needs to act as a shield to prevent its potentially live contents from causing damage and injury to passers-by. So we want to prevent those injuries and damage, injuries to people and damage to property from potentially live contents, particularly with damaged or old power cables. We also need to consider some of the common uses of service enclosures. So cable pits are commonly positioned where the cable run is required to change a direction. This is because bends in underground conduits are generally undesirable, but cable pits are used for drawing or hauling cables, are used for pulling boxes, are used for pulling cables into the enclosure, using pulling equipment, looping or feeding it to the next enclosure along the length of the cable system. In each drawing pit, though, conduits are generally aligned against opposite walls at the same elevation. So AS 3084 stipulates strict requirements for cable pulling so the cables aren't damaged during these operations. Also used as joining pits. So these enclosures can be used as joining pits, which are also called splice boxes, and they're intended for enclosing a spliced cable connection. These pits contain waterproof cable joints and are generally placed along straight sections of the cable route. These cables must be correctly sized to accommodate the size of the connector and the cables that are running through it. Service enclosures also allow the cabling and equipment associated with public utilities to be housed in a single or compartmentalised enclosure. So locating services below enhances not only the appearance of the pavement, but also improves access by service personnel. So what are the factors that we need to consider when selecting service enclosures? There are 4 key factors that need to be considered when selecting a service enclosure. Of course, choosing the right enclosure for the right application, particularly during the planning and design phase, is essential to prevent problems and product failures in the future. Some of the important factors to include is the size of the enclosure to ensure the utility and the asset housed correctly and appropriately. The location and all the intended loads of each of its locations need to be considered along the route. The type of traffic and the loading will play a significant part in selecting the correct product. For example, light vehicles versus heavy vehicles or forklifts will exert different loads on the systems. Durability of the materials needs to also be considered of both the enclosure and the cover. Ground conditions and location play a significant part in the durability of the enclosure. We also need to consider the safety and security of the system. So we need to consider the level of security that might be required and also the user requirements and the public safety requirements. However, we also need to consider the site and user requirements. In particular, how is the system going to be installed and also long-term maintained? So how will the enclosure be installed? Ultimately, a contractor will need to pick up drawings and need to carry out the installation. So is the system easy to install or is it time-consuming, which can add additional costs to the project? Ultimately, the asset holder generally carries out the maintenance in most cases. So how is that going to be carried out in an efficient and safe manner? And then we also need to consider how the systems are going to be identified. So are they identified with markings on top? Can they be identified with markings on top? And also the aesthetics. As there's different stakeholders involved in different projects, there might be an aesthetic requirement that the covers need to meet. We also need to consider the size of the system. So choosing the correct enclosure size will depend on the purpose of the enclosure. So what is it being used for? Is it an underground transformer? Is it being used for an underground GPO in an urban landscape environment or lights, which we've often seen in some of those larger civic hardscape applications. Minimum bending of the radius of the cables. So we want to try and keep those radiuses to a minimum. So we need to select the size of the pit that's appropriate for that. The minimum depth of cables. So you'll need to refer to the standards to make sure that the conduits or the fittings can be installed at the required depth. Is segregation of the cables required? And will the pit be used for storage? However, just be aware that most cable pits are narrower at the base for ease of manufacturing. So manufacturers should be able to provide all the dimensional details of the pit so you can select the correct items. And manufacturers should be able to provide those clear working areas. However, when considering location and traffic loading, it's important to be aware that, however, there is no Australian standards that actually applies to the service pits. The standard required is for the load for the covers themselves, the cover system. So designers need to consider the anticipated traffic scenario over each of the enclosures. So is there none, accidental or deliberate vehicular traffic? What are the wheel types and the loads during construction and during a service? Because often where breakages and failures can occur is during the construction phase, where, for example, there may be exposed pits and there's heavy vehicles that are driving over those pits and then cause a failure of the system. So all those phases during the construction process need to be considered. A single cable route can pass through a number of different environments, and every service pit along the cable route may be exposed to a different traffic scenario. For example, it's not going to be Class B scenario potentially through the whole cable route. There might be sections that are a higher load, for example, a Class D, and some sections are Class B. And it is important to consider that because over-design can add more cost or under-design can lead to failure. So it's about selecting the appropriate load-rated cover and service system for the right application and the load location. Some of the other factors to consider with durability is the correct enclosure construction type affects durability, which needs to be assessed during the project requirements. So some of the common materials we see in the industry are polymer concrete, which is a sand and aggregate material bound together with a polyester resin. Concrete, which is it can be in the form of either a cast in situ, poured on site, or in a precast unit. Plastic in the form of a polyethylene or a polypropylene pit, and these are available in either a single wall pit or a twin wall pit. So we've seen plastic enclosures diversify over the years from the traditional single wall pit, and we'll discuss that later in the presentation, which would be more a single wall plastic pit for more of a lighter duty application, where now in the industry we see a twin wall plastic pit which will take a much higher load, often up to a Class D. And also another material that we see in the industry is glass reinforced concrete, or GRC. But it's also important that we get the correct installation of any service enclosure, because that also will determine durability. Incorrect installation can lead to early failure, or incorrect assessment of the site conditions can lead to early failure. And life of the adjacent and supporting pavement. So it's important that we consider the durability of surrounding pavement, because if surrounding pavement fails, it can also lead to failure of the system. If we consider some of the different materials, so polymer concrete, so it is a strong composite material, 96 MPa. It's material, as I mentioned, comprising of resin hardener, aggregate and sand. Some of the advantages, it's a lightweight material, certainly compared to that of cement concrete pits, for example. The walls are very smooth. It has a low porosity. It's pretty well impermeable, which is, I think, a real advantage in the electrical space and the enclosure space. Concrete support is generally required under wheel load conditions. It's an excellent insulator. Polymer concrete has an excellent chemical resistance, excellent resistance to biological attacks. It's non-flammable and non-combustible, and has a high resistance to weathering and a low coefficient of expansion and contraction. Where plastic, and there are many types made from a variety of processes. The most common types are molded polypropylene and polyethylene. They do have an advantage where they're lightweight, they're smooth and contoured walls. Porosity varies depending on the pit type. Twin wall versions are now available. Concrete support is generally required under wheel load conditions. It's an excellent insulator. It's excellent with chemical resistance, excellent resistance to biological attacks. However, plastic is flammable, has a low resistance to weathering, and a high coefficient of expansion and contraction. Concrete, generally Portland sand and cement and aggregate with reinforced steel. One of the obvious disadvantages is quite heavy, so lifting equipment is required. Moderately smooth walls, average porosity, steel reinforced, so concrete support generally not required under wheel load conditions. It's an average insulator. It does have poor chemical resistance and poor resistance to biological attacks. It does have a high resistance to weathering, non-combustible, and a lower coefficient of expansion and contraction. And if we also consider GRC, which is cement, fine aggregates and water, and a chemical admixtures and glass fibres. So don't confuse that with concrete, as it's generally not steel reinforced. It does have an advantage where it's lightweight. It does have rough walls and exposed fibres which can cause damage. GRC does have high porosity, which is a disadvantage, particularly in cable and service enclosures. Concrete support generally required under a wheel load. It's an average insulator, but poor chemical resistance and poor resistance to biological attacks. It has an average resistance to weathering. It is non-flammable though, and has a lower coefficient of expansion and contraction. It's also worth noting with GRC, it's prone to deterioration, particularly in alkaline soils. Therefore, GRC pits require regular maintenance and in some cases are susceptible to early failure. However, we do need to consider the location in terms of durability, because adverse ground conditions may require an increase in these dimensions or the addition of reinforcement. If in doubt, engineering advice should be sought. Any concrete haunches around should be a minimum concrete strength of 25 MPa as a recommendation, because soils do apply lateral pressure on structures just from sheer its own weight, live loads and expansive soil properties. Historically, we've seen pits in expansive soils applications where they haven't been installed correctly, particularly plastic single wall pits, particularly during rainfall events where the soil becomes expansive. Push the walls of the pits in, but once it's dried out, then the pits have come back to shape again. So it's an interesting concept that we need to make sure that we consider not just the pit strength, but also the location and all the surrounding forces that will affect the durability of the pit. And manufacturers should be able to provide evidence of sidewall strength. So location determines choice. In a landscape application, with a light duty loading on a pit structure, allows for a flexible pit to be used. So when we talk about flexible pits, we're talking about plastic single wall pits. And these materials range from fiberglass, so a resin and glass mat structure, or plastic, which is what we typically see in rotational or injection molding processes. But the advantages are they're light, robust, and they're easy to use. However, in solid pavements, where there's vehicular and pedestrian traffic, a rigid pit is recommended. Rigid pits are not just used in trafficable and vehicular applications, but certainly can be used in lighter duty applications as well. So they're fairly broad in their application. So FRC, precast fibre reinforced products, Portland cement concrete pits, cast in situ, so typically boxed up pits which are poured on site. Polymer concrete pitch, which is a precast resin composite material. And the advantages are they're strong, rigid, and versatile. So in summary, single wall plastic pits for lighter duty landscape pedestrian applications, or vehicular traffic and or pedestrian applications, you want to be looking to use a rigid pit in the forms of those materials that we spoke about. Understanding the requirements of the location will determine the selection of the enclosure and cover. So there is a reasonable degree of collaboration with all the stakeholders, which may be required, particularly in high aesthetic applications, just to ensure not only the functionality of the enclosure is met, but also the aesthetic form is also achieved to meet the visual requirements of the project. We also need to consider the safety and security requirements of the cable enclosure, because people must be protected from cables and cables protected from people. And service pits must address the public and worker safety, water ingress, general unauthorised access, and particularly in these applications to comply with the asset owner's security requirements, so e.g. the government requirements for SCEC pits, because we see heavy security forces in daily events, so it's not hard to notice a sharp increase in supervision as we go about our daily lives. So the restrictions stemming from divisive and political and religious and ideological beliefs continues to tick over in the world. So now more than ever, the importance of national security to keep our country safe and secure as possible has never been more prevalent. So we need to withstand some of these disruptions to ensure the safety and well-being of all our residents. And we seek as asset holders and designers to secure our cybersecurity systems. And there are processes in place to protect national data. So to reduce the risk, we adapt a critical resilience approach to protect the integrity and reliability of our cable infrastructure in the form of high security pits. Therefore, we need to consider all the requirements of the project and the standards when selecting the appropriate enclosure. So once an appropriate location for a cable enclosure is determined and the conduit installed, preparations can be made for digging an enclosure installation. If you need to remove a full wall of a pit to install multiple conduits, you probably need to start to look at a larger pit to retain a portion of the wall. Designers and contractors must observe the regulations and codes of practice legislated by the Electrical Safety Act and refer to manufacturers' standard installation drawings for guidance. And manufacturers should be able to provide those typical installation drawings and installation methodologies, as well as recommended minimum conduit spacing on pit walls. We also consider the pit type, which will determine a long service life. Typically, GRC, FRC and polymer concrete are used in small to medium applications, have advantage where they're off the shelf. Installation under wheel traffic requires some concrete and mortar or a collar around to support either the cover and or the encasement and the edge of the pit. And these are ideal for all application types. Single wall plastic pits available in sizes from small to medium. They are off the shelf. Again, they may require some concrete, mortar or a collar encasement, depending on the application, particularly under a wheel load application. And they're ideal in a landscape or streetscape application. What's newer to the market is double-walled, twin-walled plastic pits. They do have an advantage where they are available in larger sizes, so ideal for medium to larger applications, off the shelf and also custom dimensions. Encasement is required under heavy-duty applications and they're suitable for all types of applications. And concrete, which is ideal for medium to large applications. They are off the shelf and available in custom sizes, but generally no encasement is required under a wheel load environment. In heavy-duty applications, though, custom reinforcement is required and they're suitable for all types of applications. We also need to consider the site and user requirements and the public safety and how the lids are going to be secured. So particularly with electrocution and slip resistance. So metal components within the enclosure should be kept away from electrical cables, and the absence of locking bars are the best solution. So the industry has moved away from having crossbars across the pit to lock covers down to now having a barless system, and this reduces the opportunity or the risk of cables touching bars and making the lid then live. So if required, pits should be connected to earthing structures of a building or construction via an earthing strap. And also the top surface of all lids and covers should provide at least the same slip resistance as the surrounding or the adjacent pavement, because we don't want to create a differential where we can in the two different surfaces. So we want to try and keep it as much the same as we possibly can. And these are set out in AS 4586 and HB 197. We also need to consider the worker safety of foreign materials and lifting, so the ingress of foreign matter. So excessive ingress may make the service enclosure hazardous. A degree of protection is required against objects, so needles and fingers, for example, and that's expressed as an IP rating to AS 60529. Lifting of lids for maintenance must be in accordance with the National Code of Practice or manual handling, and manufacturers should provide for all products, and lifting devices should be independently certified, and heavy castings should also have lifting anchors. We also need to consider the water resistance, and surface closures are not designed to be waterproof. However, you can achieve a reasonable degree of weather resistance by sealing the edges of the covers, making sure that the lifting holes have got caps in them, and also they're also placed back into place each time the cover's removed. Often we see that they're in there, but when the cover's removed during a maintenance regime and be able to get access to the system, those plugs are not then reinserted into the cover if removed. So that's important as part of any maintenance or service regime. Entry holes for the conduit should be capable of being sealed to prevent siltation. And pit drainage is recommended, particularly for pits positioned along SAD points. If a high level of water tightness is required, a ductile line cover sealed with grease would probably be the next best option, and we'll explore those covers shortly. We also look at cable management in terms of the cable accessories. So if they're required, pits should allow for easy attachment of cable pulling equipment. If step irons are required, hangers, brackets, bell mouth and bushes, etc. Split pits may be required for pre-existing cables, and cables and enclosures for dual services may require segregation. And segregation is not uncommon, particularly on public transport applications where different systems must be segregated, i.e. CCTV, power or hearing loops. So look for systems that enable, if you do require segregation, look for those systems that enable you to facilitate segregation. Let's have a look at this case study, which was at Pat Rafter Arena. The Queensland State Tennis Centre, encompassing the Pat Rafter Arena, was a purpose-built to broadcast matches from outside the courts, and the centre has 23 international standard tennis courts with all the major playing surfaces from hard court to clay and grass. With a cross-section of broadcasters to cater for, the designers chose a flexible communications systems that allowed for the broadcasters to set up and dismantle their external broadcast facilities as the tennis tournaments were held. And this also enabled the broadcasters to lay all their cabling system underground. And generally what they would do is remove a cover with some bollards around where they're doing filming. But that means that cables aren't laying across the surface, particularly where you have public traversing and walking over those sections where it can cause trip hazards and causing cables to be damaged and interrupt the broadcast. So they can be laid underneath, out of the way, and then localised access for the broadcasters. However, as part of the service enclosure system, we also need to consider the lids and covers. As I mentioned earlier, there is no Australian standard that applies to service pits. AS 3996 2019 governs only access covers and lids. Access cover and lids bear the direct live loads of any project. So the requirements, we need to look at the load classification. And if we compare AS 3996 2006, the deflection criteria, particularly for Class D, have tightened up from 210 kilonewtons to 240 kilonewtons. We also need to consider the durability and also the water tightness requirements. And manufacturers should be able to provide independent certified test certificates. However, it's important not to confuse vehicle weights with wheel loads, and often that's something that we see. So service pits should not be placed in areas of fast-moving traffic, i.e. roads. AS 3996 2019 gives an approximate slow-moving wheel load. So consider the axle exerting the greatest load and divide to reduce this load to only the wheels that will make contact with the lid. So often, for example, it might be a 10-tonne truck with 4 wheels, but the cover doesn't need to withstand a load of 10 tonne. It's only the wheel that's traversing that particular cover system, so 2.5 tonne. So just consider the wheel load that's going to be applied to that system, because that then, well, it considers 2 things. One, not over-designing and adding more cost in particular, but we also don't want to go the other way and under-design and then have a cover that may fail. So understanding that the wheel load that's going to be exerted on the system is important. If using standard lids, ensure the top of the pit is level with the finished pavement level. If access covers are used, the top of the pit must be set down below the pavement. So it's only set down approximately 3 mil. This just makes sure that the top of the pit is not damaged by traversing traffic and you don't have an exposed or raw edge. It's also important to note that often iron covers may not be the exact clear opening dimension to that of the pit enclosure. The clear opening of the pit, though, must not be larger than the frame opening. The frame opening of the cover and frame system can be larger, but the pit can't, because it's important that the cover and frame system is fully supported with the surrounding slab. So access covers also comprise of a separate cover and frame system installed integrally into the pavement slabs, and access covers make no contact with the pit structure, and they are generally either of solid top nature or infilled to accommodate pavement materials. One question that does come up often is using a Class D cover on a plastic pit. So again, flexible, plastic single wall pits. So plastic single wall pits, again, if you remember, are suitable for landscape and pedestrian applications. So even though the lid might be Class D, those loads can be transferred through the plastic pit. So even though a Class D cover is fully supported by the surrounding slab, but do not use a single wall plastic pit below that. If you're using a Class D cover, you need to look to a rigid pit, either a rigid pit in a polymer concrete style material, or a rigid material, or a twin walled rigid plastic pit material. That's one thing that we do see come up often. So just consider it's still the right pit for the application. Depending on the installation, certain user requirements are considered critical to the asset owner. So the access frequencies, how often do we need to have access to the system, protection against foreign objects, what's the slip resistance. We want to consider the aesthetics, identification, security. So there's lots of considerations that need to be considered to the asset owner and the maintenance crew. A manufacturer should be able to provide solutions and, where appropriate, support with documentation to meet unique client environments. So lids are available in a number of security options, either through a standard bolt, through a higher security bolt, high security SCAC pack locks. And in non-sensitive areas, heavy access covers generally do not require locking bolts, just because do not require locking bolts, particularly just because the nature of the weight, and particularly if frequent access is required, they don't want to be unlocking bolts if they need frequent access to be able to undertake any service requirements. So we consider access cover materials, and they do have a bearing on the durability. And some of those factors include the type and the frequency of traffic, the corrosion resistance, and also the weight and handling. But manufacturers should be able to provide guidance to the best materials to use against critical project requirements. So look for iron products that are manufactured from a ductile iron material. And there is a difference, because unlike typical grey iron, ductile iron has a magnesium content which allows more flex if it's overloaded, for example, where a traditional grey iron material, if overloaded, can fail in a catastrophic manner. So there certainly is a material advantage by looking for a true ductile iron material. Access covers can either be square, rectangular or circular, in a single part, 2-part or 3-part cover systems, like available in solid top configurations, available in 2 classifications of infill covers, so covers that require a structural infill and covers that do not require a structural infill. And manufacturers should be able to provide clear installation guides, particularly for covers requiring a structural infill. Infill covers allow visual continuity along the pavement or floor. They're available with a decorative edging, either in a stainless steel or a brass trim, and will enhance the appearance of the cover and the frame system, and allowing it to blend in with the surrounding pavement. Edging for iron covers is often used as a standard if paver or tiles are used, and manufacturers should be able to offer the correct depth covers to ensure the pavement materials can be supported. Access covers are specified by their clear opening, and that's the unobstructed opening of the frame. And covers are only designed to move in one direction, so they're always specified by their width and their length, which the width is across the lifting points and the length is parallel to the direction of removal. So ensure obstacles do not impede cover removal. And if we look at this image below, and very simply, it's just orientated the wrong way around so that the covers are actually removed in the direction against the wall. So whether that be a consideration that was missed during the installation phase or the design phase, I don't know. But in any case, that cover needs to be turned 180 degrees so it can be removed the other way rather than against the wall. So it makes it quite difficult to remove those covers in that application now. Also need to consider the lifting of the access covers in terms of WHS. So the cover and infill materials influence the lifting weight, and AS3996 requires the cover to have permanent marking showing the approximate mass of the cover, including any infill. According to Safe Work Australia, lifting, pulling, pushing requirements vary across each state and territory, so you need to consider the requirements in your own local authority. And mechanical lifters, both available in long and short keys, are designed for easy lifting, and manufacturers need to specify the approximate lifting weight across all access covers. AS3996 also gives performance criteria for gas and water tightness, and covers can be sealed in different ways, including the use of grease, and if sealing is required beyond 1 kPa, then bolts are also recommended as well. Also, infill covers are available in the market in a galvanised steel configuration, and these are typically sealed with a neoprene edge because it's not possible to grease seal those particular covers, so they rely on a single edge contact area with a rubber seal. Bolts are required to fasten covers into the frame or security if back pressure is anticipated, and where there are gases, there's potential for uplift. So in some instances, bolts need to be designed for the application. Stainless steel bolts are recommended for durability, and manufacturers need to provide calculation for structural bolts based on the anticipated pressures. If we look at access covers as an engineered solution, multi-pass systems are for very large enclosures. They're custom built using standard parts and pieces, and covers are supported by a beam and a continuous frame system. So all covers, and including the beams, can be removed to provide full uninterrupted access. So typically we would see a multi-part cover used, for example, for an underground transformer example. So all those covers and all the beams can remove to both lower and also remove the transformer if need be, still allowing full clear access. Trench runs are surface ducting systems for wider trenches. So trench runs are custom built using standard parts and pieces. Like multi-part systems, trench runs can accommodate all types of flooring materials, and manufacturers should help determine the optimum solution based on the total clear opening. AS3996 does not govern over large access cover systems, and this is just due to the number of removable components, including beams and individual covers. Multi-part access covers, just by their very design, cannot be made watertight, but multi-part covers are suitable for applications requiring general weather resistance on well-drained enclosures. Multi-part installations requires careful planning, and low class and pit clear opening must be confirmed, and the slab design needs to provide for the beam and frame depths and locations for the multi-part, and manufacturers should be able to provide full rebate and cover scheduling for drawings for every unique multi-part system. So these typical drawings will show all the rebate dimensions, all the beam pocket dimensions for the multi-part beams. So essentially, a contractor or an installer can pick up those drawings, build the pit to those dimensions, and the multi-part system will then fit straight into place. If we look at this case study, which is Cell Aviation Fuel Farm out of Brisbane Airport, so service enclosures are not just used for cable routes, they can be used for a variety of services. And this case study typically shows here where a fuel pipeline installation was needed to comply to the stringent safety requirements. So shut-off valves are strategically located along the pipelines, and one of the shut-off valves is located airside between both the terminals and is regularly trafficked by taxiing traffic. So a large, heavy-duty enclosure was required with a multi-pass system to be able to remove the covers and the beams and get access to the system below for maintenance requirements. Access covers where frequent access to utilities or machinery is required. There are other engineered solutions where covers are hinged to the frame and the gas strut or hydraulic arm allows for easy opening. The system contains a rubber seal ensuring a gas and watertight seal, and when opened, a galvanised steel safety gate falls into place and a stop latch holds the cover open to prevent the cover from accidentally closing. So these are for more heavy-duty applications where consistent access is required. So all of ACCO's service enclosures are available on www.accocablemate.com.au with all our range of access covers and cable pits. And ACCO also specialises in surface water management and enclosure systems for a variety of project applications. ACCO is running a international campaign, Ask ACCO. So this is providing you with technical expertise. We're here to help you through the most appropriate products and create a whole system designs that will stand the test of time. And our extensive expertise is available to you no matter what your interest or role, which is available at www.askacco.com. Just to finish off the presentation, we also have an online access cover configurator, which is really handy for designers when you're looking to find out what configurations or sizes are available, particularly with access covers. And this is available on ACCO Atrix. So thank you for today's presentation, and if I can help you with any questions, I look forward to answering them soon. Thank you.
Thank you, Greg. Good afternoon, everyone. My name is Megan Purdy and I'll moderate our Q&A this afternoon. I'll now invite our speakers to come together to take questions. So if you would like to submit a question, please do so via the chat box. If you could just please ensure you provide your name and who the question is for. Now, we did receive some questions on registration, so we might begin there. And I might kick off with Bruce. And the first question came from Mohammed in New South Wales. So Bruce, he's asked, is direct burial of cables common in rural areas?
Thanks for that question. The answer is no. They can be in high populated areas, so regional areas as well as city areas, but they're generally limited to existing assets that are quite old. Generally, newer assets that come in these days are conduited and the cable runs through the conduit itself. But they're not limited to rural areas. So my suggestion to you is when you have done your dive before you dig inquiry, if you have a look on the Telstra dive before you dig inquiry, you will see in some cases in city areas, regional areas and rural areas, you will see a line that indicates that there is a direct buried cable.
Excellent. Thanks, Bruce. Greg, I'll direct a question to yourself. And Greg, this question again came in on registration. It's from, again, Eddie from New South Wales. And his question, well, I suppose, what would be the best solution for wide trunking?
Okay, yeah, thanks for your question, Eddie. Look, for wide trunking, I think the best solution would be an engineered solution using access covers. So these would be typically arranged in a trench run configuration, and generally these are larger reinforced concrete structures which are sized according to the cable arrangement. It may also be used to cater for some coexistence of other services and utilities as well. So generally construction of these underground spaces and trenches are usually fabricated on site or cast in situ, or sometimes we see as prefabricated units. So often we see these wider trenches in both 450 wide, 600 wide, and 900 wide. That's for the wider trenching applications. In some of the narrower, smaller services, there's also cable ducting that's available up to 300 wide as well, but they're generally designed for smaller applications. So for wider would be an engineered ductile line cover in the form of a trench run.
Excellent. Thank you. Thank you very much for that one. Bruce, there was a question which came in on registration. I will get to some of our live questions because we've got a number of live questions coming in, but just one of the questions which came from Nicola in Victoria, and it was with regards to what is considered to be functional vermin and pest protection of cables.
Yeah, thanks, Nicola. Again, just sort of a nice segue on from the previous question. With conduiting of the cable, they provide a very good means, obviously, for pulling the cable through the conduit, but also basically allows a pipe to be connected directly to a pit. So when you have those combinations there, so obviously a well-maintained pit, a well-maintained chamber underneath, or pit structure, and the conduit as well. So the combination of those three things together works very well and effectively.
Awesome, thank you. Now I have a question for Greg, and this one's come in live. So very big thank you to Albert to being in the audience. Now, Greg, his question is, how do you ensure reinforcements are always enough around the manhole enclosure so it doesn't fail? What's the rule of thumb?
Yeah, thank you, Albert. And that's a good question. Look, any pit or service utility pit is part of the pavement design. Therefore, we would recommend that a civil engineer would then get involved at that stage to make sure that the surrounding pavement would support the intended loads.
Excellent, thank you. And I have a question for Bruce, which has come through live. Now, bear with me. It is the Australian standard in piping. The conduits inside the pit that you showed in the presentation should be properly labelled other than the colour coding. Can you please advise as to why some aren't labelled?
Yeah, that's a very good question. It generally comes down to the asset owner themselves, who would actually be responsible for maintaining that asset. Where the benefit comes from is where a utility locator comes in. They're able to identify who owns that asset and who they can actually trace where that asset actually goes. So in the case of the picture that were provided, that was electricity asset that actually had multiple optic fibre cables running through it. Some of those were actually labelled, and some of those the locator can identify who actually owns those and can clamp on to the actual asset themselves and trace where it goes to. So again, it just comes down to the asset owner, and that asset owner would need to then log that in their asset management side of it to actually understand when it's going in, when it's up for renewal, and the condition of that asset.
Cool. Awesome, thank you for that. And Greg, there was a question which came in from Ramesh. Now, his question was, he's keen to know whether additional requirements may need to be considered for stacker box versus ACO type pit lids in accordance with AS 3996.
Yeah, thank you for that. Thank you for that question. And I would say that both products, certainly an ACO Easy Bricks and a stacker box, are both both of a twin wall pit design. However, from an ACO perspective, we have a lot of other pits for other applications as well as Easy Bricks. Certainly, Easy Bricks is quite diverse in where it can be utilised and has the capability. It has both Class B covers and also Class D covers as well. And we can also provide full test results for the Easy Bricks pit and cover as well. So that way engineers can determine that it's the right product for the application.
Excellent. Okay. Now, I've got a question for both of you. So this question came from Jennifer in the ACT. Now, there are two parts to it. The first part, what level of remediation is required to address service enclosure deficiencies? That was the first question. And the second question was, how does this impact in existing infrastructure? So I'm not quite sure who wants to go first.
I'll have a stab first. Yeah, thanks for this question. So the first part of the question, what level of remediation is required? So generally, if we have an existing asset that we want to try and identify the deficiencies, it has to be inspected first. So as I've mentioned in my presentation, the utility locator would generally be the first one to warn of a potential problem with the enclosure or the pit manhole or conduits. That basically would move into bringing in a specialist, perhaps a structural engineer, to look at basically doing a condition assessment of that existing pit to work out what are the problems and what are the possible solutions. How does this affect the impact of the existing infrastructure? In some cases, the pit itself is actually beyond repair, so it actually needs to be pulled out completely and reinstated. It depends on where it actually needs to be reinstated. So if you have a new major road that's going through the area, it may need to be relocated itself. So you have the opportunity to mitigate that issue by basically making the existing asset redundant and relocating that asset. If it's pretty much a like-for-like situation and a normal situation where it needs repair, it comes back down to the structural assessment and what needs to happen. If it needs to get pulled out and a much larger chamber goes in, then that's where the space proofing would need to come in from probably a civil engineering side to make sure that the new structure, whatever size it is, doesn't impact the infrastructure around it.
Thanks, Bruce. Greg.
Yeah, and then I would further, and thank you, Bruce. And further to that, if there is a pre-existing infrastructure that you want to retain, but the enclosure itself needs to be replaced, and there are products available on the market in the way of a split pit, so both in a plastic configuration and also pit lock, which is a SCEC security pit, are also available in a split pit design configuration as well. So that's where split pits tend to become a real advantage, where you need to rebuild the pit or structure around it, but then don't want to disturb the existing infrastructure within that. So that's the only thing I'd like to probably add there.
Oh. All right, thank you. Thank you both. Greg, I will kind of keep the questions coming for you. I've got one which has come through from Karim. Now, his question is, have ACCO's enclosures been used for shallow applications on Department of Transport and Vic Roads projects? Is there a type approval process which we need to go through before using these?
Thank you. Yes, we have supplied access covers and pits into Vic Roads projects before. In terms of Vic Roads standards, they do have their own approved drawings and standards, and manufacturers need to make sure that they meet those standard drawings that Vic Roads have. So that's what the requirements are for Vic Roads currently, as I understand.
Thank you. Now, Bruce, I have a question for yourself, and it's come from Stuart Small, who's part of the live audience. Hi, Stuart. Thanks for your question. Now, his question is, how about straight telecommunication cabling that has been installed in stormwater and drilled through stormwater/sewage assets?
Yeah, thanks for this question. I've had experience with this sort of things before. It's really intriguing to see this. My classic example was an actual asset that was owned by electricity owner. They decommissioned the existing asset, and a gas asset owner then decided to put a high pressure gas main into this particular asset. Didn't update their records, and CCTV investigation of an existing stormwater pipe proved that. Long story short, when they couldn't get the machine over the the gas pipeline, that they had to bring in jet rodders to potentially clean the stormwater pipe itself, and the end result being that they actually smelt the presence of gas, so they actually had to abort all of the works going on site. So it does happen, and quite a lot of the time, again, that's what I was saying in my presentation there. The utility locator themselves have all this arsenal available to them, and that was a classic there where the utility locator went in not knowing anything about, apart from just putting the camera up the stormwater pipe, and there they basically saw that there was something that they couldn't get up and over. Stop work, come back with the jet rodder to clean it all out, and that's where they discovered the potential of it. And obviously, from that point onwards, there was an investigation launched of tracking down all the existing data and where it's come from, who owns it, all that sort of stuff behind the scenes. So the same sort of thing there. It does happen more often than not, but it's again, it just comes back down to getting that locator on site, getting that information, and then you can address it earlier before it becomes a problem.
Thanks, Bruce. Another question, and this one's for Greg. How do you classify the enclosure pit cover for dry well and wet well, and the standard required to be followed in design, operation, and maintenance?
Yeah, thank you. And yeah, it's a real interesting question. Different covers and enclosures are used for different purposes. So, particularly with covers and labelling, it's important that there's standards against AS3996 for marking of covers, but also local authorities within their own standards will often have their own internal requirements of what needs to be marked on top of the cover for the service that's underneath it. So that's probably the best guide I can give you in that instance.
Excellent, thank you. Now, Bruce, I've got a question, and this is one which came through on registration. Actually, it came through live, forgive me. Now, the question is, manholes are essential for maintenance and other purposes, but how are the safety measures considered? And you both may want to add to that answer.
Yeah, thanks for that question. I guess from a safety perspective, it comes back down to the asset in question. So obviously the asset itself is connected to a pit or manhole. So that itself is a direct relationship to the asset that's currently connected to it. So if that asset is quite deep, then potentially some of the assets and potential solutions from Greg's side and ACO's side may not actually be sufficient. So you come back down to a point of non-standard, which causes its own problems to begin with. But generally, from a design perspective, most utilities are pretty much from the surface level down to 1.5 metres for the purposes of constructability, but also for consideration when you are actually constructing it of digging out wider trenches for the depth of it. So generally, without having to terrace the trench, you're going down 1.5 metres before you have to make that excavation wider. So Obviously, from a maintenance point of view, obviously the deeper the asset, the more pain it is for the asset owner to maintain. Sometimes it could be a case of bury and forget, so they would encase it in concrete for that asset to basically not be dug up or maintained or anything like that. But generally, the shallower assets, yes, they can generally maintain them. For deeper assets, that's where it becomes a bit more question mark. If your comment is more around the pit itself inside of it, so it comes back down to, again, the asset owner maintaining it and how they can actually get their maintenance crews down to maintain that asset. So whether they use a winch operation, winching people down into a pit or a manhole, or whether they are actually use step irons and have safety harnesses and all that sort of thing on that side of it. So it comes back down to the individual applications and the design that you wish to do.
Excellent. Okay, then thank you for that. Greg, I'm not sure if there was anything you wanted to add to that one, but I have got another question for you.
Yeah, thank you.
So the question came through on registration, and it was how can service enclosures be improved without creating any noise during, I'll start again actually. How service enclosures can be improved without creating any noise during vehicles passing over it?
Yeah, again, another good question, and one that gets raised often, actually, and incorrect cover selection. And it can often get, well, incorrect cover selection can add to noise attenuation, and often it's one of the criteria that, although small, can get missed during some of the planning phase, but also causes, particularly if it's around residential areas, can cause quite significant issues with tenants and the residents. So the best advice I can give in that application would be to use an iron cover, using an iron cover that's also greased. So iron covers, just by the nature, have quite finely machined surfaces that mash together, so they're quite a tight fit once placed into the frame. So they're quite a tight fit, so they're not loose. Also, just the nature of the covers being weight heavy, therefore they don't rock, and also because of the machined surfaces. And having them greased as well also takes out that less of that metal-to-metal contact. And then ultimately, if you really wanted to prevent any noise attenuation, is to have those covers bolted or secured down as well. So that's the best advice I would give in that situation.
Cool. Thanks, Greg. Look, we are running out of time, so I do have another question which came in from Lachlan in Queensland, and he did direct this one to Greg. What novel service enclosures are entering the market?
Yeah, a very good question, because the market has certainly progressed over the years, where traditionally would see just standard rigid wall pits and just standard single walled plastic pits, for example. Now we see into the market different types of pits in the way of twin-walled pits. So now plastic pits aren't just restricted just to light-duty applications. We now see twin-wall pits, which are designed for more heavier-duty applications, and they're really good, particularly we see more and more of those pits being utilised in remote applications, and certainly it's less weight to install and move around and easier to make penetrations. So that's certainly an advancement in the market. We've also seen advancement in cover systems as well, and particularly if we look at access covers, galvanised access covers for pits, and this covers both single wall plastic pits and rigid polymer concrete pits through a patented system called Power Lock, and it's a barless locking mechanism for the covers. And the advantage of that is, and that was we moved away from more of a traditional bar locking system where a crossbar was inserted into the utility enclosure to lock the cover down. Now with having a barless mechanism then prevents the risk of, or reduces the risk of the cover becoming live with cables and touching that bar. And we actually have, in real life, seen situations where cables have been ripped out of enclosures, but however, not having the bar in there has prevented the cover becoming live. So it's been a real asset and risk management in the industry. So that's another advancement in the covers. And we've also seen much more developments in the high security space. So if we look at, from an ACO perspective, the ACO pitlock range, because we're seeing where traditionally you would see, say, a SCEC or high security pit in just a defence application, we're now seeing a lot broader applications where these are being utilised, where critical assets are a lot more prone to disruption and being disconnected. So I think that advancement in those high security pits is also where we've seen the market develop a lot. So yeah, there's been some really nice advancements in the industry, in the market, with both cable enclosures and also the cover systems that sit housed on top of it.
Excellent, thank you. That's all the time we have for today. So please join me in once again thanking Bruce Potter and Greg Facey for their time and insights shared at today's session. I would also like to thank Engineer Australia's industry partner ACO for making our webinar possible. And we would appreciate your feedback on the program today, so, to help us improve and plan future sessions. So please complete the short feedback form, which is linked in the description box below. Thank you again for joining us, and we hope to see you at our next webinar.